This video we're going to be talking about some different characteristics of graphs, specifically maximums, minimums, increasing, and decreasing. So let's first look at this graph here. This is just a parabola that's opening downward. So a common question that's asked, or something that we'll need to be able to determine, is when is a function increasing? When is that function decreasing? And so the key point here is that when we're talking about increasing and decreasing, we always want to give an interval along the inputs, or the x-axis, same thing. All right, so looking at this graph, we would say the function, we read a graph from left to right, okay? So kind of think about this parabola like a hill that we're climbing, okay? So we start at point A, and we're climbing, we're going up. So here's me, I'm blue. So I'm going to be climbing up and up and up and up. So I'm increasing until I get to this point, and then I'm decreasing down. I'm really tired. I'm decreasing down to point C. Okay, so we would say we're increasing between A and B, and then we would be decreasing between B and C. That would be the interval. So let's look at a less abstract example, maybe. Maybe it's less abstract. So we want to know where's this function increasing, where is it decreasing? So what interval along the x-axis are we increasing and decreasing? Well, I tend to always think about this as though I'm walking along the path of the graph. Okay, so if I start on the left-hand side, so all the way to negative infinity, if I'm walking along this graph, I'm going downhill. I'm decreasing until I get to this point right here. Then it looks like we increase up to this point. We decrease here up to from 3 to 4, and then we start to increase again. So we would say we're climbing uphill between 1 and 3, and then from 4 to infinity. Now, the question is, do we use brackets or parentheses? Well, let's look at the interval between 3 and 4. So if I'm climbing, actually let's start at 1. So if I'm climbing up here, and then what happens exactly at 3? Well, at 3, I'm no longer going up, but I haven't started to go downhill yet. So we don't include 3 in either the increase or the decrease, because at 3 I'm doing neither. We would say the change is constant. So on all of these values, it's a similar idea. So when we're increasing and decreasing, we don't include the endpoints of the intervals, and we're going to use the union symbol here. So decreasing is going to be everything else. So we're going to say from negative infinity up to 1, union 3 to 4. So those are the intervals where we're decreasing. The second trait of a graph that we want to be able to identify are its maximum values and its minimum values. And there's two different types of max and mins. There's local max and mins, and there's absolute max and mins. So let's first talk about local max and mins. So the local max and min, these are just the smallest and greatest values of the function within a given interval. Practically speaking, the local max and mins, these are sometimes they're referred to as the peaks and the valleys of a function. So looking at this graph, we have a minimum value here, we have a maximum value here. Now, we call these local max and local min because, for example, this value at 1, 2 is not the greatest point of the function, or the greatest value, because this function just continues to increase over here. And similarly, the point negative 1, 2 is not the absolute or the greatest, I'm sorry, it's not the absolutely smallest or the absolute minimum value of the function, because this function continues to decrease down here. So when we're talking about local maxes and local mins, we just means where the kind of the peaks of the function and where are the valleys, and so that's how that contrasts with an absolute max and an absolute minimum value. And when we're talking about the max and the min values, we want to know what are the output values, or what are the y values for the max and the min. Another way of thinking of this is, if you're on a hike, what is the elevation that you're achieving? So the local min would be at -2, and the local max would be at +2. And I realize I labeled this point incorrectly down here. It's -1, -2. So the local min is -2, and we may say, and that occurs when x is equal to -1. The local max, when do I achieve the highest elevation? Well, the highest elevation is 2, and that's when x is equal to 1. Finally, let's talk about what the absolute min and absolute max of a function are. Well, these are just the actual smallest and greatest values of a function. Again, if you're on a hike, where is your highest elevation, or what is your highest elevation? What is your lowest elevation? So the absolute minimum value is going to be at this point down here. That's the lowest point of the function. This value right here is going to be a local min. Okay, it's one of the low points, but it's not the absolute low point. So this will be absolute min. And then the highest point we get to is either here or here. So the absolute max is occurring at 2 different places, but the absolute max, did I say min? The absolute maximum value occurs at 2 different places, but it's 16 in either case. So we'd say the absolute min is, it looks like it's about -10, and it occurs when x is equal to 3. And then the absolute max is 16, and that occurs at x equal to -2, but also +2.